Hey, how's it going? My name's Jack, and as someone who's been learning low-code automation, namely in Make.com over the past 6 months, I wanted to put together a video that breaks down the key concepts that can help people make more sense out of the guides and the tutorials they watch. If you're anything like me and you don't have a technical background in computer science or in automation, and you're trying to learn this stuff, you've probably found that you just rewatch tutorials over and over again, and you're really just trying to make sense of a lot of these concepts when they're not necessarily intuitive to a non-technical individual. And so I wanted to just put together a video that breaks down in the simplest way possible, in the way that I made sense of these concepts, the 7 fundamental concepts that a beginner should know to be able to become minimum viably proficient with Make.com or N8N or whatever low-code tool that you're trying to learn and leverage for business use cases. So what we're going to cover are these 7 pillars of low-code automation: JSON or JavaScript object notation, parsing data, webhooks, APIs or application programming interfaces, mapping data, iterators and aggregators, and fillers and routers. So the first one, JSON or JavaScript object notation. Data that moves between modules within Make.com is commonly formatted in JSON. And upon research, the reason that this is because JSON is a very lightweight data structure that's very easy for platforms to send back and forth, and it's very operationally efficient. And so the structure of JSON consists of objects, arrays, and key value pairs. So the objects are each collection of key value pairs. So for example, in this example, or the output of a make.com module, we have 2 objects, right? One for Enrico, let's call him, and then another one for Jasmine. So the favorite sport being soccer, name is Enrico, favorite food is sashimi. That information would be considered an object. So basically the objects in the array are each collection of key value pairs. So sport, name, and favorite food are the keys in this case, where the values would be Enrico, soccer, sashimi, and then Jasmine, tennis, pho. And then the array is the entire JSON structure. So basically, this entire JSON array here, everything within these square brackets, that would be considered the array. All right, parsing data. So now that we've covered JSON, and which is, like I said, one of the most common data structures that you'll work with in low-code tools, now let's cover how to render that data usable or functional via parsing. So sometimes you'll need to parse data to get nested values before mapping them so that that data is actually usable. Basically, what that means is oftentimes you'll receive data as a string, and so the JSON string might look like this, right? You have name is Enrico, favorite food is soccer, favorite sport is soccer, and favorite food is sashimi, right? So you have an entire string there. But what if you wanted to map just the name Enrico in like a later module? Well, you do that by using the parse JSON module. And without parsing it, this string doesn't allow you to isolate and use individual data points between modules. So the best way to think about it is as if the data points are stuck inside the string until you parse that data out. And so to parse this JSON string, you just add the parse JSON module, you'd input the string, or in practice, more pragmatically, it'd be like a value, more on mapping later, but you'd get like a JSON value or an array, and then you would just put that into a parse JSON module, and then the output would look like this, right? Where you have each individual value, which is then usable. You can grab each individual item and use it in a different module so that you can, maybe you're sending an email to this person, Enrico. So aside from JSON, other common parsing use cases are email parsing. So when you get an email like order number ABC123 from Mike Jackson, email parsing lets you pull out just the order number, or just the customer first name, or just the customer's full name even. And then you can then use that information within other modules or apps in that flow or scenario as it's defined in make.com. Date parsing to convert date strings into a particular format. So different apps or services will format the date differently. So you might have one date formatted as 08/29/1958, while other platforms might read the date as 1958-08-29. Date parsing lets you convert that data into your preferred format consistently so that it shows in the format that you want it to. Text parsing, which is used to extract specific information from from messy text. So, for example, pulling phone numbers from a paragraph or splitting Conrad Murray into Conrad and Murray, so first and last name, as separate fields, so that then you could then use them, right? If, like for example, like I said, if you're sending an email, you'd want to be able to isolate just their first name so that you could put just their first name in the email, as opposed to inputting the entire string. It just wouldn't make sense. Next, we have webhooks. So webhooks are how Make.com listens for and receives data automatically from other apps. So whether that's Typeform or Stripe, or in this case, this is a flow I built for a client instantly. So that's a cold email sending platform. So like for example, in this scenario, whenever a cold email is replied to from an instantly campaign, that webhook will fire and it'll process the content of that email reply, and then I'm having ChatGPT analyze that reply as either positive or negative, and then it forwards positive replies to the necessary sales rep. So oftentimes webhooks are what's used to trigger a scenario in Make. So whenever you're triggering a scenario when an event happens, whether that's an invoice being paid, whether that's a specific type of email that you receive, a webhook triggers that scenario immediately upon that event happening, or as soon as that data comes in. So how do webhooks work in Make.com? So in cases where there's not a native app or connection for the app that you're looking to create a webhook for, you would just create a custom webhook within Make.com, and then Make would give you a custom webhook URL that you would copy. You paste that into the app that you want to receive data from, and then once it's configured, like I said, whenever that app receives data or whenever an event happens that you've configured, that scenario will run automatically or on whatever time interval that you set within Make.com. Next, we have APIs, or application programming interfaces. So an application programming interface, or an API, is how you call external services for data. So to make an API call within Make, you would use this HTTP make a request module. And if there's no native integration for an app within Make, you could still configure that API using the HTTP make a request module. So in cases where those native connections don't already exist out of the box, you would create it using, or configure it using, this HTTP make a request module. And the best way to think about APIs is kind of like a restaurant menu. So you, or the low-code platform, choose something from the menu, which is akin to sending a request, and then the kitchen, or the API, processes that request and brings it back, or the response, the webhook, the API response in that case. Or maybe even a better way to conceptualize this might be like buying groceries from a grocery store. That might be a better example because you select the items off the shelf, you go to pay, you swipe your credit card, and the API would either authenticate that request. If your credit card's good, it'll authenticate it. If for whatever reason it's like a fake credit card or it's out of funds, then it would not authenticate or process that request, and it wouldn't give you that response. So that might be a better way to think about it. So how do API calls work? So the structure of an API call consists of the following constituents, if you will. So the URL, or the endpoint, is where to send that request to. So for example, well, this is a bad example, but like Amazon, if you were looking to get listing data from Amazon, you could key in the specific API for that resource. And oftentimes resources will have like their own documentation on API, almost always, and they'll give you like copy paste examples that you can just you can copy the example and then just replace the API with your specific API, and that will work in most cases, especially for GET requests, which are rather straightforward. Next, we have the method, so the exact or the specific type of action that you're looking to call. So for example, GET, used for getting data from an external resource. This is probably the most common type of HTTP request. You also have POST, so for sending new data elsewhere. Put and patch, so for updating existing data. And then delete, so for removing data. Next, there's headers, so extra info in the format of a key value pair that you attach your request to. So think of it like showing your ID to prove that you're allowed into like an establishment that sells adult beverages, for example. APIs use headers to check your identity and know how to respond. Authorization is the header name or the key. So this key value pair would be authorization, where the value would be bearer, and then the API key. And this is just an example, right? API ABC123 XYZ. It's obviously not a real API key, but that would be the API key in this instance. So authorization is the key, where the value would be bearer followed by the API key itself. So this tells the API, hey, here's my API key, please give me access. The word bearer essentially just means, hey, I have a token, check if it's valid. And it won't always be bearer. Oftentimes resources specify to use the term bearer prior to the API key. Just look at the documentation for the service that you're looking to call, and it'll specify whether you need that or not. Request content. So sometimes depending on the API, you'll put the API key in a different field. So for example, in the request content body field. And that's generally when making a put or a replace request, then you'd specify your API key in the body using those key value pairs in JSON format. And then just a bit of additional context on APIs. You don't always, like I said, you don't always need to put the API key in the header. It kind of just depends on the API key that you're working with or the service that you're using. Many APIs require authentication via API keys and bearer tokens, as with the example that I showed above. Other APIs require significantly less authentication, and others use different methods like OAuth. So common use cases where you would need to specify the API key within the body would be post, patch, put, delete. It's very rare that you would use this in a GET request. They typically don't have bodies. And in make and then you configure the HTTP according to the expectations of the target API. In other words, just read their documentation, find an example that they use to configure the API that you're looking to, or the type of request that you're looking to call, and then just replace the API key in the example with yours. So for example, in this example here, this is weatherapi.com. So it's a free weather API where you can get real-time weather updates. And in this make scenario, this is a flow where I was taking data from a CRM that had a client's location. So I'll actually pull up this resource right now. So weatherapi.com. You can just go into their API or their docs page rather. Let's look. Yeah, so if you just go to docs here, it'll have documentation on how to use their APIs or how to make those requests. So in our case, we want the current weather. So the endpoint that we would look to call is this -current.json. So we have the base URL, and that's shown here. So the base URL here, and then the base URL is delimited by that v1. And so after the v1, there's that current.json. So that's the endpoint that we're looking to call for the real-time weather for the location that we'll provide in a second. This question mark, basically the question mark just delimits or begins your list of parameters. So in our case, we have the longitude and latitude for a specific location, and that's defined right here. So we have this Q, so the query parameter that basically starting our query parameter. So we have the question mark and then a Q, and then we have the latitude and then the longitude, which is specified right here. So it'd be like 48.8, comma, 2 point, whatever. And that's being grabbed right here, the longitude and the latitude from the CRM where that location is listed. And then finally, we have the key. So this key, the API key, and then I just blocked it out because it was actually the API key I was using in this case. That just specifies the actual API key that we're using to call this service. And this is a GET request. And so in this type of example where we're using or calling a weather API, you might be wondering, like, why would we want to do that? What's like a business use case for that? So when I just did some initial ChatGPT based research on this, like why would you want to use a weather API for real-time weather updates? Maybe you're an agricultural professional that when the chance of rain hits a certain percentage in a given location, you would forward that information to your sprinkler system to have it automatically turn on sprinkler systems. Or maybe you're Or maybe you're an event management professional that wants to send automated emails to people attending an event if there's a 50% chance or higher of rain in the location of that event. That'd be another use case that you could use this for. Maybe an e-com brand wants to automatically send modified delivery emails during severe weather. So if they're delivering, you could check that area for real-time weather updates, and if there's severe weather, you could send those emails that say, hey, due to extreme weather in this area, your package might be delayed. So just to list like a few examples of how this would be applied to a business use case. And then a common question, APIs versus webhooks. What's the difference? So a webhook is basically the opposite of an API call. So instead of you asking for data, as is the case when using APIs, for webhooks, they listen for data to come in or for an event to happen, and then it triggers a scenario automatically. Next on the list of fundamental concepts to cover is mapping. So mapping is how Make knows where to send information from one module to another, or one app to another. You're basically telling it, take this piece of information or data and put it over there. So think of mapping like giving directions. It helps Make know exactly where each piece of data should go within your workflow. So for example, if someone sends you an email and you want that message to show up in the necessary Slack channel, you would create a Slack module and map that email's subject and body variables within that Slack module using make.com or whatever low-code platform you're using. Another example, if you get new leads from Facebook and you want them saved in a Google Sheet or an Airtable, you'd map, or a Pipedrive, you would map the Facebook leads variables within the Google Sheet module or Pipedrive or Airtable, etc. So mapping is basically the process of accessing and dragging and dropping values from one module to another. And mapping is an array function. It only works on arrays. And there's a very simple mnemonic that I learned from a YouTube video when learning about mapping data in Make that basically just says, from A, I need B, where C is equal to D. And if you understand this mnemonic, then mapping is basically just a lot more accessible and a lot more intuitive. And so I have a few examples to show exactly how this works. So from A, I need B, where C is equal to D. So here we have subscriptions to a service where status equals pending. And we have this list of users and their emails. And we're looking to map the users where subscription status is equal to pending. So here we have 5 example array items, right? We have Bill Smith, Sheen Estevez, Carl Weiser, Pete Wheeler, and Pablo Sanchez. So we have 5 items within our array. In practice, you'd more likely have like thousands of items that you're looking to extract the emails of. Like if you're working with a database, there's not going to be just like 5 inputs there. There's going to be more likely hundreds or maybe multiples of thousands. And so if you wanted to extract emails of those where email status equals pending, and you have a whole list of people, some of them are active, some are canceled, others are pending, and we only want to grab those people who are pending, then what we would use is from A, I need B, where C is equal to D. So to map this bundle of arrays, we would go pending emails, and then we'd map using this map function within Make. So from the array, we want emails where the subscription status is equal to pending. And when we would hit run, it would return just the pending users. So from A, I need B, where C is equal to D. From the bundle of arrays, we want emails where subscription status is equal to pending. Pretty straightforward. Let's move into a slightly more complex example here. So let's say we have this JSON string and we want to find everyone in California. So right here we have like people in all different places. So we have Henry's in Illinois. We have Mark, who's in Colorado. Fernando is in California. And we have DeMarco lives in California, Lillian lives in North Carolina. So basically, we want to basically extract, who is it? Fernando and DeMarco, because they're both the California users. And let's say that we want to extract them from this JSON string. So here's what it would look like. From from the array, we want emails where state is equal to California, right? So that's going back to from A, I need B, where C is equal to D. From the array, we want emails where state is equal to California. And so when we use that function, it would return, like I said, these 2 fellows here, Fernando and DeMarco, because they're the 2 users out of the 5 in the array from California. And for the third example, this covers how to pull multiple objects instead of just one. So in the previous examples, we're just pulling one object that we're looking to map. But what if you wanted to pull, say the price and the product ID, and whether it's sold in the last 30 days or what have you. So in order to do that, you need to use an iterator. Say that you have this following JSON string of e-commerce products that are have been sold in the last 30 days. So you have this string, this array string right here, and it has various products and whether they were sold in the last month and the product ID and the price, the name of the product. So instead of just mapping one object, such as price, let's say that we want price and the product ID and the product name of products sold in the last 30 days. So what we would do is we would set multiple variables. We'd map the ID. So from the array, we want the ID where products sold in the last 30 days is true. We would then map the price. So from the array, we want the price where items sold in the last 30 days is equal to true. And then do the same with the product name. And then once we have the set multiple variables, we would add an iterator module. Now the iterator module, and I'll cover iterators and aggregators here in the next section, but basically iterator modules will provide a bundle order position. And the bundle order position basically specifies which object in the array corresponds with the necessary objects in the other array. So in other words, the bundle order position is how we align the ID of the product of those sold in the last 30 days with the appropriate or the corresponding price and name of those products. So basically we iterate through the ID. The iterator provides a bundle order position, and then we use the bundle order position to define and align the corresponding array items to its corresponding values. And I know that sounds a bit confusing, so I have this example here where we have an array where some of these products have been sold in the last 30 days. And then we have the set multiple variables that I just showed in that screenshot. So we have the ID that we're mapping, we have the price, and then the name. And so then we iterate through them. So iterate through the product ID. I'm just going to run this real quick just so that we can reference the actual data that we're pulling. So here we have the ID. So in this module, 18, we have this ID here. So this is going to be what we're iterating through. We're going to be iterating through the product ID, and then based on the bundle order position, we'll know which product ID corresponds to the price and the name. And so basically when we iterate through the product ID, it outputs these three collections or bundles in this case. So we have product 1, bundle order position is 1, product 3, which is the second bundle order position, and product 5. So products 1, 3, and 5 are the ones that have been sold in the last 30 days, and we have their bundle order positions here. Next, we use that text aggregator. And so this is where I was personally quite tripped up when I first started learning about this. So here we're using this JSON string. So we have the ID, so that's being pulled from this iterator right here. So this value here. So we're grabbing the product name, so 001 or 003 or 005 in this case. Then for the price, for the first bundle order position, it'll give us the price for that product. The second bundle order position, it'll give us the price for that second product, and so forth. And that's done by using this price. So this right here, within this array, we're specifying the bundle order position, so it grabs the corresponding value. And then the same thing for names. So we have the name from the output of this set multiple variables. So right here, we're getting the name that it's outputting from this formula. For example, this right here. So whether it's a cotton t-shirt or a winter coat or cotton socks, that would be like product 001, 003, 005. And so by specifying the bundle order position for the name of the product and the price of the product relative to the ID of that product, we're able to basically, I'll just show you, we'll get the output where it's this collection and we have ID product 001, price is 20 bucks, the name is cotton t-shirt. Then we have ID, then we have the ID of prod 003, price is $100, winter coat, and so forth. And then finally, since this is outputting just a long string, not a long string, but a string, I would just parse JSON, and that way it becomes usable. So we have this array, and we have the first item in the array, we have the ID of the product, the first product, and its price, and its cotton, or its name, the cotton t-shirt, and all of those values are now usable individually. We have the same for the other two products that were sold in the last 30 days. So I know that was a bit much. That might be a little out of like the broader scope of this video, but hopefully that gives you an idea of how you can start mapping data, whether that's one object or multiple. Next, we have iterators and aggregators. So we just covered iterators a little bit. So iterators, simply put, they take an array and turn it into multiple bundles. So iteration is how we can process each item in an array one at a time, rather than just, well, we wouldn't be able to process data points if we just threw the entire array at it, right? We need to be able to process them individually. So whether your array is an object or a string or a value, we want to be able to process those throughout a flow individually. And so for example, I have this flow that I built for a newsletter generation flow. So basically the iterator in this module, well, I'll start a little bit before. So I'm taking in news article links. And so I have an economics section, I have a tech section, and then a news bites, like trending news bits. And each of those have their own set of articles. So there might be like two or three articles in each section. And so basically, in this, I'm using a split formula just to separate the URLs of each link by comma. And then basically the iterator is iterating through each of those, let's say there are three links in the economic section. It's iterating through each of those three links individually. So I have three different links for the economics newsletter section, and basically it's outputting three different bundles. So the first is a link from Fast Company about a trade war. The next is a Yahoo Finance link. And we have a third and final one from The Economist. And so in this flow, basically, I'm scraping the content of each link. And so as you'll see here, there's for every flow after the iterator and before the aggregator, for every item in the array that it's iterating through, it'll consume one operation for each item that it's iterating through. So like I said, we have three links. And so every subsequent module will cost three operations. So we have the one link, another link, and then the third link. And to get it back down to one operation, you just have to aggregate that back into one. So as you can see in like the icon, you have one bundle and it's turning it into multiple bundles. And then the aggregator, this is a text aggregator, but basically it's taking multiple bundles and then turning it back down into one. So it's aggregating all those things that we just iterated through, combining it, and then everything after that maintains the one operation per run, since it's just one bundle that it's processing. So in this specific flow, we just iterated through the three different links. We scraped the text from each of those links, and then we're writing, we're basically processing the main takeaways from that news story for each link. So we have three news stories, and we're processing the main takeaways from each of those three stories, and then we're aggregating all those three stories back into one, so that it's we create a section, one section that covers all three news stories. And so that's what I mean when I say iteration lets you process each item in the array one at a time. And so every module, like I had showed in that example, every module after the iterator will run as many times as there are bundles. So we had three economics, economics section links, and so every module thereafter would run three times until we aggregate that back down. So in other words, every module after your iterator will consume one operation for every item you iterate through. If you iterate through an array with 2 items, it'll cost 2 operations. If you iterate through an array with 237 items, it'll cost 237 operations, and so forth. So to stop the per item operation cost and return to handling everything as a single bundle, you just aggregate it back down. And so to do that, you would just use the text aggregator or the array aggregator in the case of aggregating through arrays, right? Aggregators, on the other hand, are, they combine multiple bundles into one. So in this example, if I wanted to iterate, and this, I'm creating text before I'm aggregating that text back down. If I wasn't doing that, if it was like a different flow or a different use case, maybe I would have just used an array aggregator so that I could then take whatever action thereafter without like generating text using a ChatGPT or whatever else type of service. Yeah, in this case, I'm writing content based on that. And so I'm using a text aggregator because I'm generating text content. And finally, we have filters and routers. So these are pretty straightforward. Filters control whether a specific route in your scenario runs based on conditions. So they use conditions like, for example, email contains at gmail.com. If you only want to process email addresses that are Gmail addresses, then you could just create a filter in your flow for, contains, text contains at gmail.com, or email address contains at gmail.com. Another example, user status is paid. If you only wanted to have your flow or your scenario process users in a database where their user status is paid, like maybe you want to send a follow-up email to people who have purchased an info product, for example, and you only want to process that on people who have purchased it, and you have this whole list. Some people have paid, some people maybe have not. Others, like maybe they're on their free tier usage. Then you would just create a filter where user status is equal to paid. So for example, so in this flow, this is a blog, an AI blog generator or essay generator flow. And this, after the iterator that's iterating through, what is it, an input brief. It's beyond the context of this video, but basically just like a rough draft of an essay. In a specific markdown format. We're going, in this scenario, I have a filter that only processes text that starts with 2 hashtags. And in markdown format, this just means like a headline as opposed to body copy. And so we're only processing or writing content for, or producing section text for the headlines. And that starts in markdown format with 2 hashtags. And so in this flow, I'm using that filter to only process text being generated for headlines, and that's specified by text that starts with double hashtags. Routers, on the other hand, let you create branches for different logic paths. So routers allow you to process different variables in parallel. So for example, going back to that newsletter generator flow or scenario, we have this router here so that when we're taking in links for 3 different sections, we can route them to their own path, each path for their own section. So that's it for this video. Hopefully these fundamental conceptual breakdowns were helpful. Let me know if you have any questions.